The troubleshooting process. Troubleshooting is a dynamic, fluid process that requires you to make snap judgments and act on them to try and make the network go. Any attempt to cover every possible scenario will be futile at best, and probably also not in your best interest, because any reference that tried to list every troubleshooting problem will be obsolete the moment it was created. If an exhaustive listing of all network problems is impossible, then how do you decide what to do and in what order? Before you touch a single console or cable, you should remember two basic rules. To paraphrase the Hippocratic Oath, first, do no harm. If at all possible, don't make a network problem bigger than it was originally. But if I change the good doctor's phrase a bit, it's possible to formulate a rule you can actually live with. First, do not trash the data. The second rule is always make good backups. Computers can be replaced. Data that is not backed up is, at best, expensive to recover and, at worst, gone forever. No matter how complex and fancy, any troubleshooting process can be broken down into simple steps. Having a sequence of steps to follow makes the entire troubleshooting process simpler and easier because you have a clear set of goals to achieve in a specific sequence. Here are the basic steps in the troubleshooting process. Step 1. Identify the problem. A. Gather information. B. Identify symptoms. C. Question users. D. Determine if anything has changed. Step 2. Establish a theory of probable cause. A. Question the obvious. Step 3. Test the theory to determine cause. A. Once theory is confirmed, determine next steps to resolve the problem. B. If theory is not confirmed, reestablish new theory or escalate. Step 4. Establish a plan of action to resolve the problem and identify potential effects. Step 5. Implement and test the solution or escalate as necessary. Step 6. Verify full system functionality and, if applicable, implement preventative measures. Step 7. Document findings, actions, and outcomes. Identify the problem. First, identify the problem. That means grasping the true problem, rather than what someone tells you. A user might call in and complain that he can't access the internet from his workstation, for example, which could be the only problem. But the problem could also be that the entire wing of the office just went down and you've got a much bigger situation on your hands. You need to gather information, identify symptoms, question users, and determine if anything has changed on the network. Doing this will help you get to the root of the problem. Gather information, identify symptoms, and question users. If you are working directly on the affected system and not relying on somebody on the other end of a telephone to guide you, you will establish the symptoms through your observation of what is or isn't happening. If you're troubleshooting over the telephone, you will need to ask questions based on what the user is telling you. These questions can be closed-ended, which is to say there can only be a yes or no type of answer, such as, can you see a light on the front of the monitor? You can also ask open-ended questions, such as, tell me what you see on the screen. The type of question you use at any given moment depends on what information you need and on the user's knowledge level. If, for example, the user seems to be technically oriented, you will probably be able to ask more closed-ended questions because they will know what you are talking about. If, on the other hand, the user seems to be confused about what's happening, open-ended questions will allow him or her to explain in his or her own words what is going on. One of the first steps in trying to determine the cause of a problem is to understand the extent of the problem. Is it specific to one user or is it network-wide? Sometimes this entails trying to task yourself, both from the user's machine and from your own or another machine. For example, If a user is experiencing problems logging into the network, you might need to go to that user's machine and try to use his or her username to log in. Doing this tells you whether the problem is a user error of some kind, as well as enables you to see the symptoms of the problem yourself. Next, you probably want to try logging in with your own username from that machine, or have the user try to log in from another machine. In some cases, you can ask other users in the area if they are experiencing the same problem to see if the issue is affecting more than one user. Depending on the size of your network, you should find out whether the problem is occurring in only one part of your company or across the entire network. What does all of this tell you? Essentially, it tells you how big the problem is. If nobody in an entire remote office can log in, you may be able to assume that the problem is the network link or router connecting that office to the server. If nobody in any office can log in, you may be able to assume the server is down or not accepting logins. If only that one user in that one location can't log in, the problem may be with that user, that machine, or that user's account. Determine if anything has changed. The goal of this step is to identify if anything has changed that might have caused the problem. You may not have to ask many questions before the person using the problem system can tell you what has changed, but in some cases, establishing if anything has changed can take quite a bit of time and involve further work behind the scenes. Here are some examples of questions to ask. Tell me exactly what was happening when the problem occurred. Has anything been changed on the system recently? Has the system been moved recently? Notice the way I've tactfully avoided the word you, as in, have you changed anything on the system recently? This is a deliberate tactic to avoid any implied blame on the part of the user. Being nice never hurts, and it makes the whole troubleshooting process more friendly. You should also internally ask yourself some isolating questions, such as, was that machine involved in the software push last night? Or didn't a tech visit that machine this morning? Note you will only be able to answer these questions if your documentation is up to date. Sometimes, isolating a problem may require you to check system and hardware logs, such as those stored by some routers and other network devices. So make sure you know how to do this. Establish a theory of probable cause. This step comes down to experience, or good use of the support tools at your disposal, such as your knowledge base. You need to select the most probable cause from all the possible causes, so the solution you choose fixes the problem the first time. This may not always happen, but whenever possible, you want to avoid spending a whole day stabbing in the dark while the problem snores softly to itself in some cozy, neglected corner of your network. Don't forget to question the obvious. If Bob can't print to the network printer, check to see that the printer is plugged in and turned on, for example. Test the theory to determine the cause. With the third step, you need to test the theory, but do so without changing anything or risking any repercussions. If you have determined that the probable cause for Bob not being able to print is that the printer is turned off, go look. If that's the case, then you should plan out your next step to resolve the problem. Do not act yet. That comes next. If the probable cause doesn't pan out, you need to go back to step 2 and determine a new probable cause. Once you have another idea, test it. The reason you should hesitate to act at this third step is that you might not have permission to make the fix, or the fix might cause repercussions you don't fully understand yet. For example, if you walk over to the print server room to see if the printer is powered up and online and find the door padlocked, that's a whole different level of problem. Sure, the printer is turned off, but management has done it for a reason. In this sort of situation, you need to escalate the problem. To escalate has two meanings, either to inform other parties about a problem for guidance or to pass the job off to another authority who has control over the device issue that's most probably causing the problem. Let's say you have a server with a bad NIC. This server is used heavily by the accounting department, and taking it down may cause problems you don't even know about. You need to inform the accounting manager to consult with them. Alternatively, you'll come across problems over which you have no control or authority. A badly acting server across the country, hopefully, has another person in charge to whom you need to hand over the job. Establish a plan of action and identify potential effects. By this point, you should have some idea as to what the problem might be. It's time to look before you leap. An action plan defines how you are going to fix this problem. Most problems are simple, but if the problem is complex, you need to write down the steps. As you do this, think about what else might happen as you go about the repair. If you take out a switch without a replacement switch at hand, the users might experience excessive downtime while you hunt for a new switch and move them over. If you replace a router, can you restore all the old router's settings to the new one, or will you have to rebuild from scratch? Implement and test the solution or escalate as necessary. Once you think you have isolated the cause of the problem, you should decide what you think is the best way to fix it and then try your solution. Whether that's giving advice over the phone to a user, installing a replacement part, or adding a software patch. All the way through this step, try only one likely solution at a time. There is no point in installing several patches at once because then you can't tell which one fixed the problem. Similarly, there's no point in replacing several items of hardware, such as a hard disk and its controller cable, at the same time, because then you can't tell which part or parts was faulty. As you try each possibility, always document what you do and what results you get. This isn't just for a future problem either. During a lengthy troubleshooting process, it's easy to forget exactly what you tried 2 hours before or which thing you tried produced a particular result. Although being methodical may take longer, it will save time the next time. And it may enable you to pinpoint what needs to be done to stop the problem from reoccurring at all, thereby reducing future call volume to your support team. And as any support person will tell you, that's definitely worth the effort. Then you need to test the solution. This is the part everybody hates. Once you think you've fixed the problem, you should try to make it happen again. If you can't, great. But sometimes you will be able to recreate the problem, and then you know you haven't finished the job at hand. Many techs want to slide away quietly as soon as everything seems to be fine. But trust me on this, it won't impress your customer when her problem flares up again 30 seconds after you've left the building. Not to mention that you get the joy of another 2-hour car trip the next day to fix the same problem for an even more unhappy client. In the scenario where you are providing support to someone else rather than working directly on the problem, you should make her try to recreate the problem. This tells you whether she understands what you have been telling her and educates her at the same time, lessening the chance that she'll call you back later and ask, "Can we just go through that one more time?" Verify full system functionality and implement preventative measures. Okay, now that you have changed something on the system in the process of solving one problem, you must think about the wider repercussions of what you have done. If you replaced a faulty NIC in a server, for instance, well, the fact that the MAC address has changed, remember, it's built into the NIC, affect anything else, such as the logon security controls or your network management and inventory software. If you've installed a patch on a client PC, will this change the default protocol or any other default settings that may affect other functionality? If you've changed a user's security settings, will this affect his or her ability to access other network resources? This is part of testing your solution to make sure it works properly, but it also makes you think about the impact of your network on the system as a whole. Make sure you test the full system so you don't have to have a second tech called to resolve an outstanding issue. This saves time and money and helps your customer do his or her job better. Everybody wins. Also, at this time, if applicable, implement measures to avoid a repeat of the problem. If that means you need to educate the user to do or not to do something, teach him or her tactfully. If you need to install software or patch a system, do it now. Document findings, actions, and outcomes. It is vital that you document the problem, symptoms, and solutions of all support calls for two reasons. First, you're creating a support database to serve as a knowledge base for future reference, enabling everyone on the support team to identify new problems as they arise and know how to deal with them quickly, without having to duplicate someone else's research efforts. Second, documentation enables you to track problem trends and anticipate future workloads, or even to identify a particular brand or model of an item, such as a printer or a NIC, that seems to be less reliable or creates more work for you than others. Don't skip this step. It really is essential. Memorize these problem analysis steps. Step 1, identify the problem. Gather information, identify symptoms, question users, determine if anything has changed. Step 2, establish a theory of probable cause. Question the obvious. Step 3, test the theory to determine cause. Once the theory is confirmed, determine the next steps to resolve the problem. If a theory is not confirmed, reestablish a new theory or escalate. Step 4, establish a plan of action to resolve the problem and identify potential effects. Step 5, implement and test the solution or escalate as necessary. Step 6, verify full system functionality and, if applicable, implement preventative measures. Step 7, document findings, actions, and outcomes.